everyone. So today we're going to be talking about how we're automating legal workflows at 9fin. We already did the instructions, but I'm Jainisha, this is Olivia, we're from the legal team, and we've got Elliot and Jori from the data science and engineering team. So just a little bit about 9fin. We're a data and analytics platform. We provide leverage market intelligence, and we're essentially centralizing all the information that you need to analyze a credit. So that's fast news flow, it's comprehensive data, and it's predictive analytics. The debt capital markets, it's the world's largest asset class, but it uses the worst data and technology. Information is slow, opaque, and unstructured. So our mission is to organize that information using technology. And we do that in a variety of ways, but today we're going to focus on our legal tools. So we're going to do a technical walkthrough of Covenant Explorer and Covenant Data. Those are two of our legal workflow tools. Covenant Explorer is powered by a recommendation engine that turns unstructured data into semi-structured data. And Covenant Data is powered by an LLM engine that turns semi-structured data into structured data. So first, having a look at Covenant Explorer. On any given day, the legal team has to review multiple deals, and each of these deals can have a document in excess of 500 pages. So we need to condense this information down quickly and show the key clauses to our clients. So we do this using Covenant Explorer, and we're essentially turning data from an unstructured PDF into semi-structured data. And as you can see, we've got a deal here. There's up to 50 rows of data, and that obviously depends on how detailed the document is. And then we can also help our clients do a side-by-side comparison with other deals in the market. And that's really helpful. For example, if you've got the same company, you might want to compare their different debt packages. We also have a red line tool that then shows you the differences between the two documents, and an auto summary tool, which essentially condenses down the information even further and just picks out the numerical baskets. Like I said, Covenant Explorer is powered by a recommendation engine, and I'm going to hand over to Jori now to talk a little bit more about how that recommendation engine works.
Hi, everyone. Like Jainisha just said, our platform provides the ability to view all these documents and view all the paragraphs, labeled paragraphs within, in the platform. And to be able to create these data sets, we, for a couple of years ago, built an annotation engine. And this annotation engine has been in use, like you can see, since 2021, and internally it's called 9tag. This has been a cross-functional effort from a couple of teams, the legal team and the engineering team, as you can see here. And over the years, our legal team has been using this annotation tool to tag up to 60,000 annotations which are available on our platform. And on the right-hand side on the slide, you can see how a typical workflow for a legal user is within this tool. They would select a document, scroll through, start reading the legal section of the document, and then for the paragraphs that require a label, they would click on the paragraph to select it, and then just assign a label. As you can see, quite a labor-intensive task for our legal users. So this clearly requires some automation, which is why we're here tonight. But on top of this annotation engine, we built a recommendation engine where the main goal is to reduce the annotation time for our legal team. This is, again, a cross-functional effort between legal, engineering, and now myself, joined from the data science team. And we've, as you can see on the right-hand side, it's the same tool, but now now the user is not reading the document, it's just cycling through a number of recommendations made by our recommendation engine. So they just need to accept or reject recommendations while they're looking at the content of the recommendation. This has been a process of a number of iterations. One of the first iterations involved a fairly naive bag of words approach with an XGBoost model on top of it. The problem there kind of was that that there was a low explainability of these recommendations. Our users who are interacting with the recommendations would like to know where the recommendation came from and what the logic was why we recommend said recommendation. So we took a step back after getting this feedback, and we basically asked ourselves the question, what are we exactly trying to automate here? So the question was, what is an annotation exactly? And as you can see, an annotation is a combination of a number of text selections within this legal section of this offering document. And the legal section can be up to 100 pages. So the selection could come from anywhere in those 100 pages. Of course, an annotation has a label. An annotation also has a structured data point that can be extracted from it, which Elliot will talk more about in a minute. But then a very important point is that these annotations should be consistent across the highly similar legal documents that we analyze, because this is a data quality question where our end users care if they would be comparing two deals that are highly similar, that those data points are extracted from exactly the same paragraph, and that's something, yeah, we really care about. So that's, yeah, what an annotation exactly is. And then when we went one step further and trying to automate the creation of these annotations, we really analyzed the workflow of the manual workflow to create these annotations. And the manual process is, like I said, they read and they tag the document as they go through these, like I said, up to 100 pages of a legal section of an offering document. They come up with some tags. And like I said, it's very important that these tags are consistent across the highly similar documents that we have in our database. So they would identify a highly similar document and then compare the annotations both in these highly similar documents and then make corrections where needed. So a very labor-intensive process that involves a lot of reading, tagging, and correcting. How did we automate this process? We first automatically identified a similar document. We used some hashed n-grams with Jacquard similarity algorithm to do this, and we also rely on Elastic for this. We query the annotations just from the database from this highly similar document, and then we overlay these annotations on top of the new document and by basically scanning the new document with a partial alignment algorithm. Great. This is, voila. These are the results that we got for this. We've been cycling through a number of iterations where the initial iterations were only able to carry over full paragraph selections, and later on we were able to carry over any kind of selection, so single lines, words, etc. And as you can see, while we were iterating, we tried to keep the precision very high while improving our recall, which worked, which we're very pleased about, that it worked very well. Of course, everything I talked about right now is what's been in production for a couple of months at 9fin. We're working on a lot of exciting new tools to do these tasks. One of them is fully automated tagging. As I mentioned before, at the moment, tags have to be manually rejected or accepted by a legal analyst. The main reason for this is, like I said, we really care about this data quality because this is what we sell on our platform. And in the future, we will try to statistically diminish the amount of annotation, amount of recommendations that need to be accepted without losing the data quality, basically. If I said 60K annotated paragraphs, I think a lot of people in the room might be thinking about leveraging more of Elastic's features for this. This is something we're investing a lot of time in at the moment. You can see the tagging tool on the right, and for one of the main features that we're trying to implement next is where a tagger, instead of just annotating a recommendation based on one similar document, they would be able to query our whole universe of labeled documents, which runs into the thousands of documents, which would make our annotation tool a lot smarter. Down the line, we can give the users on our platform access to these indexes that we built in Elastic. so that actually our end user on the 9fin platform could navigate these documents, one paragraph at a time. And then last but not least, on top of our platform, we have a RAG system built, which is called 9fin AI. At the moment, we're gradually expanding the document types this 9fin AI RAG system has access to. So once we build these indexes in Elastic, we'll be able to give our RAG system also access to these documents, which will make the amount of information it can return a lot bigger. Voila, a lot of exciting things to come for this recommendation engine. And now I'll hand over to Olivia, who will explain the governance data.
Cool, thank you, Jori. So just to recap what Jori has ran us through, Covenant Explorer is powered by our recommendation engine and our annotation engine. And I won't take credit for doing 60,000 annotations, but I've done a lot of annotations. And the annotations are great. Covenant Explorer is a great tool. It allows people to compare documents side by side, seeing the essential information that they want in a tabular format. But at the end of the day, it's still PDF text. It's not structured data. It's not a database that people can query. That's where Covenant data comes in. So with Covenant data, what we're really trying to do is turn that semi-structured data into structured data. And the ambition here, as you can imagine, I had more of an incentive than anyone, being a person doing the annotations, is to layer data science solutions on top of what we had. We really didn't want to create a separate workflow where we're inputting data manually into a table. So what we did is we have this vast repository of annotations, and we're using those annotations to extract data points. And to extract those data points, we're powering that with an LLM engine. And by doing that, we've been able to build a database, which you can see in the GIF here, which is fully filterable and sortable. And I will let Elliot explain further how the LLM engine works. Thank you.
Thank you, Olivia. Hello, everyone. Today, I'm going to run you through the technical side of the Covenant data solution. So our problem statement was to turn semi-structured text, as Olivia mentioned, to structured data. So these data points are constrained to a JSON schema. This specifies the structure of our data, for example, what fields the data point will contain and what data type they will be. So as Olivia mentioned, this is going to let our users search and filter the Covenant data. So I'll just run you through the flow of what happens when a user wants to create a data point. So the user will highlight text in the annotation. This will then be passed to the LLM. This is augmented with previously verified data points by a legal analyst. The LLM will then suggest some values for the data point. If the data point is correct, the user accepts the data point with no further interference. If not, the user will go and manually edit the data point. Once the data point is accepted, the data point is created, and then created data points will then be displayed on the summary screen to users and used by the LLM as an example in future uses. So let's take a look at how we build the prompt for the LLM. So number one on the graph, you can see this is the user content we provide to the LLM. This is built from the top n most lexically similar data points that have already been tagged. This is a technique called n-shot learning. And luckily in our case, legal text is quite formulaic. This means we didn't need to use an embeddings model for the sentiment analysis. A simple bag of words approach is more than sufficient. We then go to point 3, where we use the JSON schema of the chosen data point to instruct the LLM of what to create. This is done via function calling. A really good resource on this that we were inspired by is the instructor Python library. If anyone's familiar with that, I'd recommend checking that out. And then if we look at point 4, this is the output that the LM suggests, structured data from the text, which is really, really good and saves the legal analysts a load of time. So let's take a look at the results of Covenant data here. So since the Covenant data feature was launched on 9fin, we've tagged over 6,000 data points. Currently, 1/3 of all of our data points are created solely by the LLM. This means the legal analyst only had to verify the LLM's output and make no additional edits. The interesting part about this graph is it doesn't capture the times when the LLM gets some of the data correct. which means that, you know, the full usefulness of the LLM isn't really captured. Like sometimes the LLM will get 2 out of 3 of the fields correct and the analyst will only have to edit 1, and this isn't reflected in the graph. But so we imagine the positive output, the LLM is much greater. So some of the future developments we want to try is smaller and faster models. So early on when this process started, we ran some experiments and we found for our case, end-shot learning performs well with smaller models. Currently we're using GPT 3.5 Turbo, which is fairly quick, but we could go quicker. And this will, you know, if we get a smaller model, will result in quicker inference. Then we want to try some prompt engineering. So an example of this is we want to tell the LLM it is an expert legal analysis. Quite wishful, I know, but this is there's been papers on this. It's called expert prompting, and we've seen some positive results. So we'd like to try experimenting with that. And thirdly is JSON schema hinting. So currently under the hood, our JSON schema variable names are not the easiest to understand. An example is the grower field in our baskets data point. The only context the LLM is getting about this is from previous examples. We can add a description field to JSON schema that might help the LLM find the grower within the semi-structured text. And ultimately, by the end of this, we want to end up with fully automated data point creation. We have a really good internal BI tool called Metabase that lets us monitor how the LLM is performing on different data point types. Once the LLM performance is very high on certain types, we can easily allow those types to be created fully automatically without a human in the loop. So thanks for listening. Any questions? Oh, okay. Oh, we got a second mic coming.
Second mic is coming.
Thank you. Very interesting. The title said, or the agenda said, you improve the speed at which the lawyers do their analysis. Can you comment on how you improve the speed?
Yeah, so I know we have some quantitative analysis in our Metabase, but I think for now some qualitative feedback would be good.
Yeah, happy to comment on that. Depends what kind of work we're doing, but when it comes to writing our reports, essentially using the Covenant Explorer feature allows us to very quickly have a summary of the key baskets, they're called, the key essential information that we will use to write our reports. But there are also more ad hoc tasks we'll have to do, like if we need to look for examples of certain text, or we want to see how different companies or different documents have a particular clause. Covenant Explorer, for example, is a really quick way for us to do that. So whereas before you'd have to look through, let's say 6, 7 different PDFs, open it up, try and go to the right page, maybe open it side by side or copy paste it into an Excel file or a document. On Covenant Explorer, you just go there and type in the company or document name, and you get it all side by side. You can change the rows, filter it, and you can, with our redline tools, see the differences between the different texts. Similarly, with Covenant data, if I'm looking for examples where we've seen a particular clause before, or a particular, sorry, without getting into the specifics, like if I want to filter essentially for particular features of a clause, I can just get a list of examples right away. I don't have to rely on my memory. Oh, I think I saw that one time in a document. It's all there. So all of that speeds up our workflow tremendously.
Great question. Who's next? Straight in the middle. I love it. Bear with, bear with.
Thank you. The documents you're comparing must be sensitive. And I'm assuming that you are provided by your clients with them. And I can imagine that in some cases your clients will have been on different sides of a deal, or they weren't necessarily involved with a deal. But how do you stop using part of the LLM generated from client A's data flowing in to B's data?
Yeah, really good question. So currently, I might butcher the legal side of this now, but to my understanding, a bond is public and a loan is private. Yes, I got that right. So we only have Covenant data, the LLM stuff for bonds at the minute, which are all public. But with the loan, when we get to implementing for Cov data for loans, so the loan text is encrypted at rest, and we, a simple SQL query. We just won't pass any loan data to other loans. That's like the safest option I think we could go for. We could go more granular with our control, but we haven't got to that yet. But yeah, that's a really good question.
Thank you. Thank you both. Was there any other questions? Come on. I'm looking. Come on. Bear with. Now I can see 3 or 4, but I can see. I'm looking for a female voice. Where are we looking? There we go. Come on. Girl power.
Hey guys, I have a question on the model you're using. So why are you using 3.5 turbo as opposed to like Omni or 4?
Yeah, great question. Oh, sorry, it's really bad. Simple answer is we have a internal LLM tool set up, connected to Azure that our data science team manage. So this is like a Lambda, an AWS Lambda, if you're familiar with that basically lets any technical backend team just communicate to an LLM easily via invoking a Lambda. So you don't have to install any packages. But essentially, that was the only model at the start that the data science team had set up. That's why in the future we're gonna like experiment with different models and we're gonna try them all. Our data science team has a really good platform for testing different models. So yeah, basically a business decision.
Amazing. We'll take one more question and then we'll jump into our second talk. But the guys will be around all night as well, so grab them over a beer and pizza. So I feel bad for missing you last time, eh? Come on.
Oh. Thank you. I guess, as you said, butchering the legal side, I guess, could you walk us through in a 10,000 feet view what exactly that the legal team needed to do when you said it was reviewing the clause? Like, what's the problem, and what's the problem that the legal team is trying to solve, and how comparing PDF side by side is slow, and then eventually now with this tool that I believe is more like turning PDF into a table, so it helps you to process information a bit faster. But I guess that's the 10,000 feet question that I wanted to ask.
Yeah, sure. So I think as Elliot or Jori mentioned, these documents are really formulaic. So it's not like every time you read it, you're reading like something completely different. It's very similar clauses from document to document, but what will vary between these clauses is the numerical data that's inside. It's a lot of the time numerical, not always. Sometimes some of the data we're gathering could be just Boolean data, but a lot of the time it's just numerical. And what our clients are looking for, and therefore the work that we do, is centered around extracting this numerical information. We do a bit more than that, of course. That is a key thing that we do, and which the Covenant Explorer and Covenant Data helps with. It's like that numerical information we're extracting. Yeah, does that answer your question?
So it's like a product research, basically. Like, for example, I want to put this loan now, and then I want to see what's the market like, for example.
Exactly, like people want to know if something is market. So that's where Covenant Data really comes onto its own, because it's like, it's a database. You can see how many times has this basket been at 50% before, or at 500 million. Yeah, there you go.
Amazing. Thank you so much. Thank you so much. Can we have a round of applause, please, for 9 minutes?